Let's take this problem. This problem says that acceleration of a car started at t equal to 0 varies with time as shown in the figure. Now let's look at the figure. The figure shows that this is the time axis. From time equal to 0 to time equal to 10 seconds, the acceleration is 5 feet per second square, uniform acceleration. But from time equal to 10 seconds to time equal to 20 seconds, the acceleration is 0. And from time equal to 20 seconds to time equal to 30 seconds, the acceleration is minus 5. That means there is to find out the distance traveled in 30 seconds. That means the distance traveled from here to here. So let's first recap the three basic equations of kinematics: V equal to U plus Ft, S equal to Ut plus half Ft square, and V square equal to U square plus 2Fs, where V is equal to the final velocity, U is the initial velocity, F is the acceleration, E is the time lapsed. So let us first consider this part and say the distance traveled during these first 10 seconds is S1. And this time, the body has an acceleration. So you can use this equation, the second equation, to find S1. S1 is equal to Ut plus half. F is 5 multiplied by t is 10 seconds. From here to here is 10 seconds, so 100. So this is equal to 5 into 50 equal to 250 feet. So in first 7 seconds, it moved 250 feet. Now let us consider the distance traveled in second 10 seconds is S2. During this time, it had no acceleration, it was a fixed velocity. So if we know the velocity at this point, that means at 10th second, then that velocity multiplied by another 10 seconds will be the distance traveled S2. So what is the velocity here? Let us consider the velocity here is V1. That means the final velocity after the first stage. We can find out this velocity by using this equation V is equal to U plus Ft. So V1 is equal to U is once again 0, F is 5, T is 10 seconds, is equal to, this is 500 feet. So S2 is 500 feet. Now let us consider this distance is, during this time, it has also an acceleration, but negative acceleration. And the velocity here, initial velocity here is of course the same velocity V1. That means, sorry, there was something wrong here. The V1 is not 500, but 50 feet. 50 feet per second. So V1 is equal to 50 feet per second. So this velocity here is also, it is 50 feet per second. So in the third part, the initial velocity is 50 feet per second. So the S3, again using the second equation, will be Ut. U is here 50. multiplied by time is 10 minus, because here the acceleration is minus half, f is 5, t square is 10 square. This is equal to 500 minus 100. This 100 divided by 2 is equal to 50 here. So 50 into 5 is 250. So this is another 250 feet. So the three distances traveled is 250 feet, and did not find S2. S2 is equal to 50 feet per second multiplied by 10 second is equal to 500 feet. So this is S1, 250 feet. S2 is 500 feet. S3 is 250 feet. So total distance traveled is 1000 feet. So this is the answer. So this is one answer. The next part of the question is rather tricky. In fact, that is the tricky part of this whole question. The next question is draw the time position time graph. Right? So in order to draw the position time graph, what do? We draw some axis first. Say this is the time axis, and then this is the line for 10 seconds. This is the line for 50 seconds, and this is the line for 30 seconds. So this is position S, this is 0, this is 10, this is 30. Now we find the total distance is 1000 feet. So at the 30th second, let us say it has reached here. So, and let us say this is 1000. So this is 1 point of motion. This is another point of motion because it started from 0. Now let us find out let us draw the other ordinates. This is 750, this is 500, and this is at the end of first 10 seconds, it did travel 250 feet. So this is 1 point of motion. And at the end of 20th second, it had traveled 250 feet plus 500 feet, that is 750 feet. This is another point of motion. Now we have to draw the curve. That is the trick. This curve will not be a straight line curve, but one part, this part will be a straight line because this is a part where the particle moved with uniform velocity. If a particle moves with uniform velocity, then its displacement versus time curve will, of course, be a straight line. Now, what about the first part? In the first part, there is an acceleration. So the displacement versus time curve is a parabolic curve. Now, let me answer you why. Why do I say it's a parabolic curve? Let us consider a sample here. This is the time, and let us consider that acceleration is constant. This is acceleration F. If acceleration is constant, then we know velocity V is equal to df dt, that is time domain differential of the acceleration. And if acceleration is a constant, then time domain differential will be equal to some constant k multiplied by time. So the velocity, if acceleration is concerned, then velocity curve will be a straight line like this. And if it starts from zero rest, then it passes through the origin. If it starts with some initial velocity, then it will pass through some coordinate like this. Once again, we know that S displacement equal to dv. So if this is the velocity curve, which is actually a y equal to mx plus c curve, c here is 0. And since s equal to, v equal to velocity equal to ds dt, therefore s is equal to integration of v in time domain, right? So if this is the curve, straight line curve y equal to mx plus c, then integration of y will be some constant k2 multiplied by x squared. That means displacement curve will be a parabolic curve or a square law curve. This will be the displacement curve. This. Other way around, if the displacement curve is a parabolic square law curve, then velocity curve is an inclined straight line and acceleration is a constant value. That is why this part of the curve will be parabolic. Once again, this part of the curve also will be parabolic, but it will look like this. Because here there is a retardation, that means velocity gradually decreases. And you can see that if you differentiate, the slope of this curve gradually decreases. That means here its differentiation value decreases gradually. So this is actually the position time graph, right?